A block is sitting on a wedge that has an inclined angle theta. Both the block and the wedge have mass m and are at rest. What are the static frictions between the block and the wedge, and between the wedge and the ground? So let's start by drawing a few diagrams. So this one is going to be of both the wedge and the block. So this is the system of the wedge and the block. So pushing up, you would have the normal force. Pushing down, opposing normal force, you would have 2 mg. Since they both have mass m and they're sitting on top of each other, their total mass would be 2m. And to get the weight, we just multiply that by g, the gravitational acceleration. So this is the block and wedge. Now for the block, if it's sitting on some sort of incline here, let's say that this is the block. So the normal force is going to be acting perpendicular to the inclined surface. The force of gravity is going to be pulling it down, and there is a friction force that is keeping it up, and this is the force of static friction. And again, we can decompose the gravity vector down into its individual components. There's a right angle here. This is theta. That's theta. And so this becomes mg sine theta, and this becomes mg cosine theta. And this is, if you use some basic trigonometry, the component parallel to the incline is mg sine theta. The one perpendicular to it is mg cosine theta. And then we have one more, which is the diagram for the wedge, which I'm going to draw like this. So yeah, I really just need a single dot. So again, you have the normal force. This is a different normal force acting on it from the one on the block, and you have mg acting down, and then from the block on it, you have the normal force that is pushing it back down, and as well as the force of static friction that is pulling it back to keep the block atop the wedge. But these don't matter, because if we look at this, the wedge, there is simply just no static friction between it and the table, because there are only vertical forces acting on it. So the force of static friction between of the wedge and the ground is simply equal to 0 newtons. That's one of them. Now to figure out the force of static friction between the wedge and the block, you can simply say that the force of static friction minus mg sine theta, the component of gravity that is parallel to the incline, or to the surface of the wedge, is equal to the mass times acceleration, which is equal to 0, since the block and wedge are both at rest. So from that, we can say that the force of static friction acting on the block, between the block and the wedge, is equal to mg sine theta. And this third free body diagram can be used to check these answers if you would like, but this is how you would solve this problem here.